Hello, this is my video number 40 on computer technology, specifically on Jane, the system I'm writing. And we're going to be looking at programming values. How do we create values, and how do we locate them and manage them and use them? So we first look at communication, which are sounds. The words that we use, we make sounds to communicate, and we communicate through our words. We have about 7,100 living spoken languages in the world today. So French, English, things like. Over the history of humans, there have been, they estimate, about 31,000 languages. So the words we use, tree, bush, car, these are the things that we want to use to represent our knowledge base. It's communication. And in the communication, we have about 100 counting systems. Over the course of humans, we use the base 10, and in computers, we use base 2, binary system. So we have bases of 10, 2, mixed bases of time, so 7 days a week, 60 seconds, and so on. And then we have a base offset from some value, and then we have an offset from that. This is in our computer systems mainly. And then we have spoken numbers. So we, here in the US, will do 92 as 9 tens and 2. In French, it's 4 20s and 12. And in Danish, it's 4.5 times 20 and 2. So everybody counts differently. And we in the computer industry kind of think that everything is just simple numbers, but they're not. And this is what we have to really realize, is that we really have to speak in 31,000 languages. And we have 100 counting systems. And then we have counting systems on counting systems, and everybody has a different base. So there's probably a couple thousand different ways to represent numbers. And I don't know how many ways to represent our communication, our vocabulary. Our communication representation in computers are switches. So we have maybe millions or billions of switches that we represent digits with. So it's like 1 if by land, 2 if by sea, or none of them, then not yet. So these are not positional. This is a communication method, and we can have an unlimited number of candles. In our computer switches, we are not that lucky. It is positional. It all depends on the computer too. What position represents what? We really don't have a standard. And we're limited to a certain number of bits, maybe 4, maybe 8, 16, 32, 64, maybe 32, maybe 41. They're all different. We have no standardized way to represent the number of bits that we can represent a number with. And our CPU hard-coded number representations, to us, to the computer, they're just bits, and we think of them as numbers. And then these numbers are used for numbers, of course, and as characters. So this number, these sets of bits, represents character A, and these sets of bits means B, and so on. And then we represent date and time, things like that. True and false with the number of bits. And then each programmer has a personal preference on how he wants to represent anything else. So the computer does a few operations on numbers and moves them around within memory, and the rest is left up to the programmer. And it's pretty much a religion or a cult. So I looked up the definition. Religions are widely accepted, established belief systems with established structures and scriptures, while cults are characterized by intense devotion to a leader, secrecy, and potentially harmful practices. I kind of think of it as a cult, but I should be nice and just say it's a religion. So the value, our switches, our hardware bits, and it's going to somehow record our human and our computer understanding, what the human understands, what the computer understands. It understands, the CPU, the registers, the things that it has access to. And then we have devices attached which have their own understanding. How does the mouse work? What is it expecting from us? And what should we expect from it? And same way with our application. We have billions of applications that are all isolated, all building their own proprietary data structures. And then we have personal understanding, my understanding of what that particular video means or what that picture represents. To me, it might represent a cat. To somebody else, it might represent a tiger. And to somebody else, it might just be fluffy. So we all have a different understanding. We have 7 billion people, everybody with a different understanding. And that's what we're trying to record. So we use words and numbers and pictures. This is our limitation on what we can represent. And then our relationships. So we have a value and it has certain relationships. Most of these are assumed. We never determine those. We hard code the relationships in each individual application. And then we have location of the things that we want to store. So we have memory and we have storage, and we may have services that have information, bit settings that are going to be sent to us, and then we have to understand and represent those. And then we should have partitions, which is a location for most of our information is partitioned. We don't really have partitions in our systems, but invoices that have been paid and not paid, that's a partition of some kind, whether it's logical or physical. And then we need movable context. So we have these values and we'd like to be able to move that context around. This is getting into sharing of our values, and then sharing of logic, which is some logic has to be moved. How do we count? How do we calculate age? That needs a value of a birth date if we're talking about humans. If it's somebody else or a different type, it's all in context. And then we need a visual representation of this knowledge. So it would be nice to be able to visual representation of all the knowledge that we have. So if we have math equations, we should be able to represent that as we write on paper. Music, chemistry, physics, vegetation, transportation, every technology has its own way to visualize it, and so the computer needs to have that capability for everything. And then finally we have an address of the value. Where is it? So I'll first look at JavaScript's value locations, which is pretty much standard, a little overblown, we'll see here in a minute, but basically we're looking at a name equals value. So this is our whole context for all the values that we have within our current computer technology. So it's going to either be text, it's going to be a number, it's going to be null or undefined or true or false, and that's pretty much the capabilities of our compilers. And in JavaScript, we use a global variable called window, and it is basically the main function's local values. And then we have functions. All the functions have local values. In JavaScript, we use the var. In all the different languages, they simply declare a variable local or global. And then we have statement blocks sometimes that these values are only valid within a block of code. And then we have the parent functions locals. So if A has a subroutine called B included in its description, then when A calls B, B has access to all of A local values and its parents. And then we child function names. So when A knows that B is a child, A knows where B is. No, anything outside of A does not know where B is. And then we have the value of this, which is either implied or explicit. It's some hidden value that is passed to a particular name. And then prototype, which is if not found, is literally if we didn't find it in the above list of things, then it's a linked list of the constructor of this. And then we have a get and set parent values. We have the addresses of the value. I'm going to call it a cell, just something that contains the value and all the information related to it. So the address, where could we have, what value could we have? We could have a process. This is a application that is running, so that process has a name, that process has certain information about it, and so the cell itself could be the process, and it could contain all the statements, all the data structures, and everything that particular process knows. Or it could be a machine. You know, my machine, my wife's phone is a machine, my refrigerator, my TVs. So these could be the address of where to start looking. Or it could be on a CPU core. So my machine may have 6 different cores, and each one I could access and have knowledge that it knows. And then we cast. So we have a value and we may cast it as a different type. So it might be a number, but I'd like to cast it as text, or vice versa. Or I could cast it as anything else that I could represent that particular value as. I could cast it as hex values, or octal, or decimal, or whatever representation, and be able to do that. And then we have a storage device that the cell is at. The storage device could be the cell. But what I'm saying here is the cell is unique in the sense that it is everything. And then we have an input device, and then we have an input and output device, and then we have just an output device. So these are the kinds of things that we need to know if we're going to deal with it. And then we have memory, and we have an operating system, which has information. And then we have a thread, and a partition, and a structure. So we could have an address, a street address, and the street address has a structure to it. And we can break that down, and then one of the values could be city. And then we could have a row as in a table, or a column, or a group. So I want columns 1 through 3. I'll group those into, I'll say, prefix, or call it something. So we can name, and that could be a cell. Or we can have alternate names, and indexed. So it could be named, or it could be indexed. So I want employee sub 1. Or it could be a selection. I want the employees from Houston. Or it could be derived, as in age. Now the cell's context. Okay, we have a value out there somewhere, and we need to be able to access it, then the first thing we're going to have is the value itself. The value here is 12. And we're going to say it has an identifier. So I'll say it's area of the sidewalk. The percent sign says you can stop there if you wish when you're using it within your application or when you reference it. So in this particular context, wherever I'm in, I can just say area. I don't have to say, I could say both, area of the sidewalk. And then the cast name. So I could cast it as a number or text or a CSV or an address or a URL or whatever. The value itself, we need to retain exactly what it can be cast as. And generally, we can cast just about anything to anything. So if we wanted to cast text as an image, we could do that. And then units, so square feet, miles per second. We have to have this information. This is our context. And this is part of the value. This is what I'm getting to. And then what is it? Is this a person or a dog? You said 12. You put a name on it, but exactly what is that? And we should have that ability. This is from after the value and the identifier is what we have today. We don't have anything else. We hard coded in our source code. I'm saying, look, we got to get it out of our source code and put it here. So what is this? This is a dog, a person, a disc driver, a wheel, and then we have a domain. So it could be we may be a drop-down list. So it could be red, white, or blue, and nothing else. It could have a range from, of area. It could be age. Well, it's from 0 to 130 years or something. Or it could be that it's a counting number. So it starts at 1 and goes to infinity. And then the relationship. So let's say it's something, and here's a wheel, it's a child of the car. So I need to know that. It's not a wheel of a tricycle. So these information, it's not our job to determine use of anything, but if we're going to share information, this is getting to sharing. If we share information, all of this thing has to be out of the application and into the value itself. So we have source code. So we say area equals height times width. That might be useful to somebody. Do we have to put any of this information in there? No, we have to have the capability to put this information in there. And then logic. So age, is it open? I mean, is that value? Is it feet to meters or English to French or any of the other logic that is specific to this value? How do we convert that? If we want to take 12 and convert it to French, then we have to be able to do that as numbers and as words. And location. So this is very important. Where is this value? I'm in an application. Where is it? It's on my wife's phone, in contacts, and I'm talking about me. So I have a value called area of the sidewalk in my contacts for some reason. And style. So we need style capabilities of what we can represent on our computer. So is it blue? Is it bold? Is it underlined? Is it English words? So here I want to say, when I see this visualized, I want to see it in English words. I want 12, not 1, 2. And events. So we'd like to be able to put events on this. Okay, in my application, I'm using this value, but I want to be able to hover over it or click it or do a right click to pull up context, and then I can even put that context right here if that's what it's taking our application and extracting what's common to every application out there, and then we build a system that this is automatically done for us. So if we want to put in events, or styles or the source code so that the end user can say, look, pop up that source code when I do a right click, or pop up a context and let me pick what I want to see. We do these things, and this is not anything new. So the cell is basically the value, but I want that value, a single value, to contain all this information, and then be able to store this value, share the value, query it, whatever I want to do with this value, and actually use some of it in when I render it, or when I need to find it. When I need to find it, where did it come from? Doesn't necessarily that's where I'm storing it. Anyway, there's a billion pieces of logic here that we're taking out of all of our applications and consolidating them so that we can access values. And so it's share. I want to share. So I want everything out of the application source code. Look, I'm sharing this information so you don't have to look at my source code to figure out that information. And half the time we can't figure it out because it's in the programmer's head. What units? We have no idea. I was working for Conoco, and the lead engineer gave me they had a PhD, did some analysis on gas pipeline pressures and things, and so I did the calculations for him, and he comes up to me and he says, well, what units? I says, I have no idea. She didn't write them down. I don't know, what the units were. And then we have single value assignment. So when I say A equals area, A now contains all that information that area is. So when I move this or give it to somebody, that has it. So I can say A.source code or some syntax. We'll come up with some syntax that makes a little bit more sense, but you get the point, I hope. And then circular assignment, meaning that we can cast these things. We can go from storage to memory to storage to just rendering to an image and back and everything. So this is what we're trying to do, and this is all automated. You just say, look, this is a number, but now I want it to be in binary. I want to see the zeros and ones, or hex or octal, or I want it to go to storage now, and I want to pull it out. And searchable. So we want to be able to search these internal values. So I can say, search my global variables where the value is equal to 12. Editable. So I need to be able to change these values of the identifier. I just want to call it area now, lowercase. Whether this, I really want to go to case insensitive. This case sensitive garbage is nuts. Okay. So we want all this to be compiler automation. So this is all built into the compiler. All we do is we put the values in, and then the system handles the rest. So it does our storage and retrieval. It does the visualization for us so that when we have mathematics, it actually looks like mathematics as we write on paper. It might be a little bit extra work for us as a programmer, but once we do this, it's done. And then communication. So how do we get all this? How do we get to all the devices that we want to get to? That's all automated for us. That's a little bit more work on the hardware side, but we can get there without programming ourselves to death, trying to track all this. This should all be done for us. And then the transportation. How do we get it there? What is the means of that? And then the context, which is really, in our current software development, we have no context. We either have it global or local, and then as arguments really in our functions. That's how we communicate. So we communicate with no context whatsoever. But in this system, we put everything in context. And then it's searchable. So we can search anything. And then we can apply logic and casting. So the casting says, okay, yes, this is a CSV, so whatever I could do with a CSV, show it as a table, convert it to something else, or cast it as just a file, as a binary file, or cast it as, just lines of text. We could do all kinds of things automatically for ourselves. And then validation. So if we know it's units, we have to have the units. And if we need to, and then we can validate, are those units correct? And if we have to convert it, let's say I'm sending my whole land survey over to England, everything needs to be in meters, not standard feet units, that kind of thing. So it's validation and actually conversion, translation from system to system. So my conclusion is we want to reduce software development time. So by doing this, we really don't have 90% of our application is done for us. We get readable source code. So I can read the source code. It has all the information I need, and it's not in the programmer's head. This is like our pictures when we had pictures and we developed them. We had the pictures in our hand. We could write on the back of them. That's what we're doing here. We're writing on the back of our knowledge exactly what the application needs, and then the application doesn't have to do this work. It knows, oh, this is feet. Fine, I can work with that. I can convert it to meters. I can do this work automatically without having to write programs, which is what we're doing now. We're writing billions and billions of programs, and each of them have to start out with just a name value logic. And we want user editable logic. So when he says, oh, well, he didn't, look, he has a style here, it says blue, I'll just change it to red and I'm done. And we have access to everything. So every bit value in the world. So all of our binary structures and everything else is automatically done for us. Yes, it's in that executable. And an executable has sections and code sections and data sections, and we can access those. And everything else, that every file and every structure that we build will be accessible on all machines, everywhere. And we can share anything. And we want a computer technology for everyone, not billions of applications. We want one. A technology doesn't care what the value is or what its purpose is. If somebody says, look, I have graphics, I want to just plot this area, it's up to the user, not up to the application. Right now, we have applications that do one specific thing with one particular data structure. No one else can access that information, not as it is. All right, that's it. Thanks. Until next time. Bye now.